So there's the 0.44. Let's call that A. Okay, that's C. All right. Okay, so what we're going to do here is we're going to dilate centered at C, and we want to find the image of A. So currently, the distance from C to A is a change in y of 1, and it's a change in x of 2. And we want to take those, okay, and we want to multiply them by the scale factor. So change in y is 1. So what we want to do is we want to say 1 times 3 equals 3. That's going to be your new change in y. Change in x is 2. 2 times 3 is 6. We're going to go, so what we're going to do is we're going to go, looks like down, because we want to keep the same direction going. We're going to go down 3, and we're going to go left 6 to keep going in the same direction. 1, 2, 3, 4, 5, 6. A prime should land right there. And if you notice, C, A prime, they're all collinear. Okay, that's how it works. A is 3 times as far from C as, so A prime is 3 times as far from C as A is, using both of the directions. So I think we land over at -2, 1. And that's choice A. Next, the equation of a line. All right, first thing I'll do with this is get it in mx plus b form. So let's add 2x to both sides. So we get y equals 2x plus 6, y-intercept of 6. Okay, 2x means we're going to go up 2, right 1, up 2, right 1, over down 2, left 1. Okay. Now, we want to center this dilation at the origin. Okay, if I have a straight edge, I draw that, but okay. What I tend to do with dilations, I try to figure out a distance. If you can get a nice point, either straight up and down or straight across, I would use it. I'm going to use this straight up and down. I'm going to call this my point A. Okay, I'm going to see where this lands. It's currently 1, 2, 3, 4, 5, 6. The change in y for A, okay, that's equal to 6. Now, when I dilate it, what's going to happen is I'm going to date 6 times 4/3, okay, turns into 8. So my new change in y for A prime from the center is going to be 1, 2, 3, 4, 5, 6, 7, 8 in the same direction, so there's A prime. Now, my line should stay parallel because dilations preserve slope. We must remember that. Meaning, you have to have the same slope. So really simply, this was nice because you see they're parallel, right? This was really nice because all that happened was A kind of kicked up to A prime right there. So the new y-intercept is at 8. So all we're going to do with a new line, so the image, okay, it's going to be y equals 2x. Now that's going to happen because we should preserve slope. But then we're going to possibly have a new y-intercept. In this case, it's +8. So there's our image. All right, same type of problem down here, except no center at the origin. Okay, so our center is going to be at 210. I think that's right there. Let's just double check. Yeah, that's 210. That's our new center. We'll call it C. And, okay, so we have same equation. Add 2x to both sides. So let's graph. Oh, wait a minute. Okay. So there's no work to be done. The center of dilation is on our line. So the image, this is automatic, is the same line. Okay, here's what we got to say to justify it. Okay, so when we dilate a line and the center of dilation is on that line, the image is the same line. All right, so let's clear this up though. Now points will move, individual points will move, such as this one. Okay, say I make that point A. That point will move, but it'll move along the line. So let's say we do a change in x for that point. Okay, it's going to be 2. Right, we multiply that by 4/3. It's going to be a decimal. That's no good. Let's try another one. Let's call this point A. Yeah, let's just use a different one. Change in x there is 3. Now, 4/3 times 3. 3 times 4/3 is 4. So what's going to happen is we're going to move over 4, but we're going to keep along the same line. It's going to land right there at A prime. It's going to be your change of in x equals 4. Okay? I could show you the calculation. Change in y here. This was 6. 6 times 4/3 is 8. So you saw the change had to be 8, which it was. So that worked. So individual points will move along these lines, but it's still ultimately the same line. So that's what we had. All right, that rounds out, I think. Yeah, that's everything on the review packet. Work hard at that, study for the test, and hope you do well. Thanks so much.